here. So what we need to do is we need to bring what we're trying to figure out and we cancel it. So in order to do that, we bring this here, the grams of Na3CO3, we bring it down here. So it comes here. It turns into grams of Na3CO3. So it turns into that. We bring this here, and then again we times it. I'll bring it down over here. We times it. This, then we need to figure out what goes on top. So since we're trying to convert these grams into the mole, so it goes into from grams to mole. So how many in a mole? How many grams of this is there in a mole? So that's what we're trying to figure out. So we put mole of Na3CO3. So there you go. And 1 mole of this has 106 grams. This here has 106 grams. 1 mole of this has 106 grams. So that's what we put here, and that's how you figure out which ones go on top, which one goes on the bottom, which one is the denominator, which in the denominator. The last fraction in the denominator is always going to be a 1 as well. So you can get those out of the way from just knowing that these will always be 1s when doing math stoichiometry. So after you do this, after you put in all the numbers, put in all what you need to do, it's simple multiplication from across. You can't do it like this. The reason I'm doing it like this is because I don't have space, but here I'll show. So the way this should be written is, hopefully I can get it one try. Let's see, is 1,000 grams Na2CO3 times grams of 2CO3 mole of Na2CO3 times mole of Na2CO3, and then I do mole of NaOH, mole of NaOH, and then so at the end, this is what it should look like. This is what the equation is. There's a bit of a glare that you can't see in the bottom here, but yeah, there's something there. It's the single mole right there. So 1 mole of Na2CO3 is what there is. That's there. Okay, and then from there is just simple multiplication from across. So it'd be 1,000 times this times this times this. So it'd be 1,000 times 1 times 2 times 40. You do this into a calculator and you should get so if this is typed into a calculator here, it'd be 1,000 times 1 times 2 times 40 here, you'd get 80,000, and that would be the top number. So that'd be the top number, which is 80,000. That's the top number. Now you must figure out the bottom number. So it'd be this times this times this. So 106. So again, there's a 1. That's a 1. So it'd be 106 times 1 times 1 times 1 and obviously 106. So we do this like this, 1,000, and then we just divide. So it'd be 80,000 divided by 106, which is, and then 7, then so it'd be 754.7, and this is going to be the grams of what we were trying to figure out in AOH. And that's how you solve a mass-to-mass stoichiometry problem. Yep, that's how you do it. So